before starting numericals, we have a few rules for solving these derivatives, differential coefficients. So suppose C here is a constant, we can write it as this. For C is a constant, suppose this is a constant, we can write it like this. And we have D, suppose there is anything A plus B upon dx. This will be equal to dA upon dx plus dB upon dx. The next rule that we have is DAB, A and B are in D, and differential coefficient of product of A and B upon dx is equal to A dB upon dx plus B dA upon dx. Okay, also in any physics formula, let us suppose anything that has strange powers. Okay, consider anything z that is given by any physics formula. This is just hypothetical. Any physics formula that involves variables like this, b raised to power 3 upon 2, suppose anything c. Okay, we can write it like this using differentiation upon z equal to 4 multiplied by triangle delta a upon a plus 3 multiplied by delta b upon b. This is very we are going to ignore any constants like 2, and negative values of power are also ignored. We just take positive values of power. Okay, this is a very useful relation. This is called relation of fractional errors and is useful in error analysis, for which we may talk about some other day. For those who already know what is error analysis, this is a very useful relation. So next relation that we are going to see, next rule in derivatives that we are going to see is d a upon b upon dx is equal to, now we are going to write this like this: a d differential coefficient of b on differential coefficient of x minus b dA upon dx. These are going to be very useful relations for numericals, so consider learning them. Upon the square of this b square, that is b square, and the final relation that we are going to have is, it's just a general thing, dy upon dx is equal to, we can write it like this: dot product with any quantity, suppose dA. This would just cancel out to be 1. Okay, so we can write this like this also: dy upon dA dot dA upon dx. This is a very useful relation in many derivations. This also comes in derivation of the position time relation for Newton's for Newton's equation of motion, position time relation. So these were the properties